Hello everybody, my name is Mervin XuYang Lim and I'm a third year PhD student in the Department of Chemical and Environmental Engineering at the University of Arizona. And the short title of my video today is Universal Pretreatment System for High Recovery of Water from Concentrated Brine. So before we get into that, let's talk a little bit about reverse osmosis because this is where the brine comes from. Reverse osmosis is the most widely used water purification technology in the world. As you can see in this picture, this is a real reverse osmosis water treatment plant in Tarpon Springs, Florida, and it is used to desalinate water, which is the act of removing salt from water for potable use. This is how reverse osmosis works. You have a semi-permeable membrane. You can think of it as a cloth that is so tightly knit together that only water molecule can go through. And feedstock is the dirty water that we want to purify. When we apply pressure on the feedstock onto the membrane, we squeeze the purified water to one side, and the leftover water that's more contaminated is known as brine. So my project focuses on reclaiming brine. However, in order to do that, there's two big challenges that we need to address, and they're both membrane related. We might have seen them in our daily life. The first one is scaling, which is mineral buildup, and we can see this hard water scale on our shower head, right? And for fouling, it's organic matter buildup. And if you have an aquarium, you can see the biofilm on aquarium tank. That is a type of fouling. And these two problems, scaling and foulings, are prevalent in membrane-related treatments. And so my project focuses on transforming brine into a valuable product. And how do we do that? We split the water, H2O, into elemental H plus and OH minus using electricity. If you look at the picture to the right, that is a very small unit that I'm working on in the lab. And how it works is we have H2O, water, and sodium chloride, NaCl, go into the chamber of this cell, and we apply electricity to transform this product into H plus and OH minus. So H2O is basically being split by electricity into their elemental form. And then we can use this elemental form acid, for instance, we put it with the scrap iron filings, and we mix it in a reactor, and then it creates a type of coagulant, which is a chemical that binds others compound together and sink to the bottom of the cone, as you can see, brown substances that we can then dispose of. As for the base, it's the same thing that we do, except the white particles that you see at the bottom of the cone are calcium and magnesium solids. And this is my experimental setup at West Center, Tucson, Arizona. This block you see here in black is our reverse osmosis unit that we run our experiments on. And the main finding that we have is we have 90% reduction in calcium and magnesium ions and 45% reduction in organic matters. If you look in the picture from number 1 to number 5, with number 1 being the raw water that we want to purify, number 5 is the purified water. And I would like to acknowledge the team, my professor, Dr. Andrea Achille, and US Army for the funding that I received to conduct these experiments. Thank you.